My name is Mr. Mustafa, and today we are going to do some chemical calculations. So we will learn how to calculate volume and concentration of a solution in a titration equation. So first of all, let's have a look at what equations we use in solving these questions. First of all, we have a simple triangle that relates or simplify the relationship between the number of moles, concentration, and the volume. So since the n number of moles is above the C and V, if you divide the number of moles by any of them, you get the other. Example of that is the volume is equal to the number of moles divided by the concentration, and the concentration equal the number of moles divided by the volume. Makes things easy and simple. And the number of moles at the same time equal C times V, concentration times volume. The second equation we are going to look at is C1V1 over N1 equals C2V2 over N2. As with all titrations, we always have acid and alkali, and we can choose anyone to be 1 and anyone to be 2, but I like to have a routine, so I start with the burette number 1 and the flask number 2. So C is the concentration, V is the volume, N is the number of moles. So this is our solution number 1, the acid, and our solution number 2 is the sodium hydroxide. Let's see the first question. A laboratory technician was titrating sodium hydroxide with dilute sulfuric acid. Find or calculate the concentration of the sodium hydroxide solution. So since our concentration is expressed in mole per liter, it is better to express the volume in liters. So 22.5 divided by 1000 would give us the volume in liter, and 25 divided by 1000 again will give us the volume in liters. So let's see what we have here. We have acid, and it is indicated by red arrows because the acid has low pH, and in the universal indicator it is red in color. The sodium hydroxide is blue in color because it is an alkali, and the pH ranges from 10 to 14, so the color will be blue. Anyway, the second thing we look at is the number of moles. So balancing the equation is already balanced, so having 2 beside the sodium hydroxide means we have 2 moles. Having no numbers next to the sulfuric acid doesn't mean that we have 0 moles. It means we have 1 mole. So let's write our equation and substitute our numbers in the equation. So 0.1 times 0.0225 divided by 1 equals C2 multiplied by 0.025 divided by 2. And then we cross multiply. Cross multiplication makes life easier when it comes to changing the subject. So let's see how the equation looks like. 2 times 0.1 times 0.0225 equal C2 multiplied by the concentration and the volume, and then multiplied by each other is 0.0045 equals C2 times 0.025. That means the concentration is equal to 0.025 divided by 0.0045. That means our concentration is 5.5 mole per liter, and we shouldn't forget to write the units and express the units in the right format. So it is mole per liter. The second question is again sulfuric acid with sodium with potassium hydroxide, and this time we are required to find the volume of the acid. So first of all, we identify the volume and concentration of the acid. So the volume is unknown and the concentration is 0.25. For the potassium hydroxide, we have 25 cubic centimeter and 1 mole per liter concentration. So V1 is unknown and V2 is expressed in liter, and our number of moles identified. We have 1 mole for the sulfuric acid and 2 mole for the potassium hydroxide. So now we list our V, C and N neatly and find out what data we have. This is our equation: C1 V1 over N1 equals C2 V2 over N2, and we substitute our numbers in the equation and then we cross multiply. Now we can simplify by multiplying the numbers. So 0.5 V1 equal 0.025, and then V1 equal 0.025 divided by 0.5. That means our volume is 0.05 liter. We shouldn't forget to write the units. This is in liters and our volume is expressed in cubic centimeters. So to express it in cubic centimeter, we multiply by 1000, which is 50 cubic centimeters. Thank you.